Hello students. So in today's class, we are going to discuss about how to design a PCR program. We already discussed what are the different stages or steps of PCR. So we have an initial denaturation stage followed by 30 cycles of the 3 steps of denaturation, annealing followed by extension. So we have 30 cycles of these 3 steps. This is then followed by final extension step, and lastly you have the hold temperature where the PCR reaction is stopped. So AHA 1474, this was the gene for which we had already designed the primers. So these are our 2 primers, forward and reverse primers, which we had designed in the last class. So now we'll look at how do we design a PCR program for amplification of the gene 1474 using the given primers. Okay, so our question is to design a PCR program for amplification of a DNA fragment using Taq DNA polymerase. So we have first stage is your initial denaturation, which in case of Taq DNA polymerase is going to be at 95 degrees Celsius, and the time can be about 5 minutes. Okay. This is then followed by 30 cycles of the 3 steps of PCR, that is denaturation, annealing, and extension. So the denaturation here is again going to be at the same temperature, that is 95 degrees Celsius. Time can be less over here, about 30 seconds. Okay. This is then followed by annealing. Okay. So for deciding on the annealing temperature, we need to look at the TM of your primers. So I will go back a slide, and here you can see the TM of my 2 primers is 60 degrees and 63.1 degrees. Okay, so this is the TM. So my annealing is going to be 5 degrees less than the TM of the primer, that is lower in value. So of these 2 TM values, 60 degree is the lower value. So I need to have my annealing at 5 degrees less than the TM of this primer. So it can be 55 degrees, which is also the standard annealing temperature that is used. So sometimes, for example, if my TM value is 59 degrees, then I need to set up my annealing temperature at 54 degrees. Okay. However, I don't want to have my TM of the primer as low as I try to keep it above 60. I don't want to have it the TM value around maybe 55. Then I'll have to keep my annealing further lower around 50. So at which temperature, at which annealing temperature PCR doesn't, it may not work that well. So preferred temperature, annealing temperature would be 55 degrees. And so we might have to redesign the primer accordingly so that the TM of the primers is 60 or above. Okay, if you want to use 55 as the annealing temperature. Okay, so in this example, I can use the annealing temperature as 55 degrees Celsius, and time can be again around 10 seconds is okay. And then comes the extension. So the standard temperature for extension is 72 degrees Celsius. And the time that we would do the extension will depend on the size of the fragment that we are amplifying. So I need to check the size of the gene. So I'll just copy the locus number and go to KEGG. I can search the gene, and you can see that it is 1104 nucleotides in length. Okay, so this is 1104 nucleotides in length. So when you're using this enzyme, Taq polymerase, it can amplify. It can do amplification of 1000 base pairs per minute. Okay, it can amplify 1000 base pairs per minute. So accordingly, my fragment size is how much? Is 1104. So I need to calculate how much seconds or how much extension time I need for 1104 seconds, for 1104 base pairs, sorry. So you just need to calculate that it is 1 minute for 1000 base pairs. Then how much do you need for 1104 base pairs by cross multiplication? And this comes out to 67 seconds. Okay. Then your final extension is again going to be at the same temperature as your extension temperature. However, the time is going to be 10 minutes. The final extension is basically to complete any partially amplified fragments that the final extension gives an extra time to complete those fragments. And then you have the final hold temperature, which is going to be 4 to 10 degrees Celsius. Okay, so at this, the reaction is basically going to stop and no further extension will take place. Now, this is when we do the amplification using Taq DNA polymerase. However, if we want to do the amplification using the other enzyme, let me change the question. So using the other enzyme, that is fusion polymerase. Okay. So again, so when we make use of fusion polymerase and when do we make use of Taq polymerase? First of all, Taq polymerase is used when you're doing a PCR basically for screening purposes normally. But if you're majorly using the amplification product for cloning purposes, then you need to make use of fusion polymerase enzyme because it has much higher accuracy compared to Taq polymerase. Okay. Now, when you are using fusion DNA polymerase, the denaturation temperature, initial denaturation, first of all, is going to change. It is going to be 98 degrees Celsius. The time can be same. Okay. Then we have the 30 cycles of the 3 steps of denaturation, annealing, and extension. So here again, the denaturation temperature is going to be 98 degrees Celsius and time will be 30 seconds again. Annealing is going to be identical because this is based on the TM of the primers. And extension, the temperature is going to be identical, that is 72 degrees Celsius. However, the time is going to decrease here because fusion polymerase can amplify 1000 base pairs in 30 seconds. Okay. So accordingly, I'm going to just divide this value by 2 so that I can get how much extension time I need. So it is going to be about 34. Okay, I need 34 seconds as the extension time. Final extension again is going to be same and the whole temperature again is going to be identical. So that's it about how do you set up a PCR program using Taq and fusion DNA polymerase.